All right, you guys should be able to hear me now, hopefully. If you don't hear anything, maybe someone put something in the YouTube chat or the Discord chat. My stream audio is now enabled. So, hello! Okay, without further ado, I'll try and get this going. So, welcome to the third workshop of assembly. You probably saw earlier I had this little sort of drone assembly open here that's sort of like a half put together, just because I was fooling around with it earlier. Like I mentioned before, just go ahead and make sure you guys have the required files downloaded. I'll have them somewhere in my files here. So, for example, I have it here, Drone Workshop V3 Pack and Go. Yours might have a slightly different name. It's probably called Drone Workshop 3 Assembly PDF. So, as long as you guys have those required files downloaded, you should be good to go with this workshop. So I'll just go ahead and get it started. So just to reiterate, assembly is the process of putting together all your parts. You define how parts are put together. So for an example, you can constrain two axes, for example, like the center axis of a screw and the center axis of the hole that it's going into. You constrain those two elements of parts together, and that's how Inventor knows how the parts want to be put together and constrains it in the environment. It sounds strange and a little complicated when I put it like that, but trust me, it won't be as daunting as we go through this. So to make up for lost time, I'll go ahead and get started. I'm going to try and make Val or Aiden, if you guys want to if you guys want to make any polls in chat for like if something is too fast or too slow, just so we can get some feedback as we go along with stuff, that would be great. Just so you guys don't have to pipe up and tell me if I'm going too fast or too slow, you can just click a button in the YouTube stream. But I'll go ahead and get started here. I'm just going to go ahead and go to File, New, up at the top. The same process we do for starting out literally anything. And you should be met here with your usual menu here, your metric. And in the previous two workshops, we've only done standard millimeter.ipt, so that is Inventor part files. We're not going to be using that this time because that's a part file. This time, instead, we're going to be using an assembly file, which is the same thing, just in the next category down, the standard millimeter.iam. Now, basically your assembly, your IAM file, is made up of a bunch of IPT files put together. So, if I go ahead and click that, click Create, it'll open up my, my assembly environment here. Now, right away, if you're familiar with the part modeling environment, you should see that we have a new tab open here up at the top, and it's called Assemble. So normally, if you were making a part, you'd be in the 3D Model tab, and you can make sketches, extrusions, etc., just like that. But today we're going to be working in the Assembly tab. So you can see we have a bunch of different options here that are going to look pretty foreign if you haven't used Assembly before. But they're actually not all that complicated, and we're only going to be using a few of these. Now, to actually start out my assembly, you actually need to add parts to it, right? So to go up to add parts to our assembly, currently we have nothing here. All the parts will show up in the modeling tree on the left. To actually add parts, you go Place up at the top. There's even other options if you want, if you have different file formats. For example, if you wanted to import an STL file into it, that's what you do. But we're just going to go with the regular Place this time. And now in your Place component dialog should open up, and you should just navigate to wherever you saved that zip file on your computer, and wherever you extracted it. Make sure you extracted the zip file, by the way, so that it's in an actual folder that that Inventor can recognize. So you should have some parts similarly named to these ones, except you won't have this drone assembly final there, hopefully. And to actually get going, I believe our first part is called Central Unit Body. So we're going to go ahead and click on Central Unit Body, and you go ahead and click Open there at the bottom. And now you should see this sort of like ghostly, translucent form of the main body part that you're going to be adding in. And you can see it's just kind of like floating in space. There's nothing you can really attach it to. For example, just to give reference back to our part modeling workshops, whenever you started a sketch, you can always start the sketch and then use the origin point as your starting point. But in this case, we don't really have anything to select. So just to start it off, just click. That places it down, and you're good to go. However, you'll see that the tool probably stays open, and you'll still have this sort of this ghostly looking translucent preview going around following your cursor. To get rid of that, just click Escape on your keyboard, because we only want one of these parts, so we don't want to place multiple of them. Once your screen looks somewhat like mine, you can see it looks good. Like we opened it up on our screen and everything. But if I just kind of show you a reference back to the other part file I had open earlier, here, for example, this looks different, right? It's almost like there's more contrast on it. You can actually see the edges. That's because in assembly, this is my biggest pet peeve in Inventor. Anyone who has worked with me before knows this. You can go to View, the View tab up at the top. If you want to see the edges more clearly, you go to the View tab, and you can change Visual Style. You go to the drop down there, and change. Currently, it's on Shaded. We're going to be changing it to Shaded with Edges. So you can see the preview there shows the dark edges on the part, whereas shaded, it just looks smooth. So shaded would be good if you're using like renders, whereas shaded with edges is good if you're just trying to make some edits. So I'm just going to change that real quick, and then we have our part in here. Now, before I actually start to go add other parts in, there's one extremely important step I have to do. That is, I need to set this part as my base part. By that, I mean, this part is going to be the one that doesn't move anywhere in the assembly. Picture it as like the reference part for attaching all the other ones in the assembly. To actually make this part our reference part or base part, whatever you want to call it, we just select it in our environment here. You right click and you click grounded. Make sure grounded is checked off. So you'll have this large menu here with all these different options. There'll be transparency, contact sets, adaptive. I don't know what that means. But just go ahead and make sure if there isn't a check mark next to it, click it. And now if you go back to it again, there should be a check mark, and then just leave it like that. So just make sure you have this part set as your grounded part. This is the most important step, I promise you. And you won't be able to tell it's the most important step unless you forget it one time, and then all your parts are like waving around each other when you're trying to put them into place. So if you guys stuck around sort of towards the end of the last workshop, you might be familiar with this process already, but I just wanted to give it a little more in-depth explanation. Now, if I go back to my other part here, just as a reference, you can see we have this lid on the top. This is the lid we made in the last workshop. We 3D modeled it. So I'm going to actually place this into my assembly as well. To do that, I go back up to Place up in the top left. Go ahead and click. And then you're going to want to now select the Central Unit Lid.ipt file here. Once you find that one, again, that's Central Unit Lid, just to repeat myself, just to make sure everyone's on the same page. Once you have that selected, you can double click it, or you can click it and then go Open here at the bottom. Doesn't matter what you do. Open is the default option. And then same sort of scenario, right? It's a transparent part following around your cursor. Just go ahead and click it down wherever you feel comfortable with. and then hit escape on your keyboard just to exit out that tool. So now I have my part in here, and I can move this. By the way, you can try this out yourself if you want. First, try this part you just placed, this central unit lid. Just go ahead and click it with your cursor, just left click, and drag it around. See, it can move freely in all directions, right? If I just rotate my screen here, you can see I can move it wherever I want. But if I try to do the same thing with my base part, I can't do it. It cannot be moved, and that's because we grounded it. And that's exactly what we want. So basically, we can treat this base part as the same thing that the origin would be. The origin point would be in your 3D modeling sketches. So now I'm actually going to add this lid onto my base. And to do that, we're going to be using constraints. Now, you are probably familiar with constraints when you're sketching things in the 3D modeling environment. For example, we had like coincident constraints if you wanted to connect a point to a line in a sketch, or vertical constraints if you wanted to make a line, vertical in your sketch. Now, those are 3D modeling sketching constraints. Here we have assembly constraints. They gave them the same name, I know, but it sort of makes sense once you get more familiar with it. So if we actually go up to our constraint menu here, if you just click it, you can see it'll open up this dialog box that's quite small. I would make it bigger if I could, so sorry about that. But you can see there's a few different types here. We've got 5 different categories. You have mates, angles, tangents, inserts, and symmetry. Now, each of these types has different solutions. So, for example, here under our mates, our first solution is a mate. Now, a mate, if you look at the little icons, you can see sort of normal vectors coming out of planes that are sort of going against each other in opposing directions. And to give you sort of visual, the visual I always use for a mate is if I wanted to clap my hands. Picture my hands are just 3D models, right? And picture I just have my hands in an assembly. I can just, a mate would be if I selected my left palm and my right palm, then it would mate them together, and then I'd be doing this sort of, prayer pose or whatever, or like clapping basically, right? So you could technically, if you had 2 3D models of hands, you could make like a dynamic simulation of someone clapping. Not sure why you would do that, but you could. So that's what a mate is. And then you have these other ones here, flush. So flush is similar, except instead of the vectors opposing each other, they're going in the same direction as each other. So flush would be if I had my hands out like this. The planes of my palms are now collinear, basically, right? They're parallel. That's what I should say. So we're actually going to be using mates for most of this. Well, for this part particularly. Now, I'm actually going to exit out of this constraint menu to make my life a little bit easier. I'll show you guys a little life hack here. God, cringe. So what I usually do to sort of help Inventor use its smart skills is before I start constraining parts and constraining them where I want them to go, I usually orient them a little bit so you can actually rotate your parts in your assembly individually. And to do that, you select them and then you click G on your keyboard, or you can click free rotate here up at the top. Same thing, but I prefer just clicking G. It's a nice, it's a nice little shortcut. And now I just kind of rotate it around. You can click and drag with your left mouse button, and then I kind of rotate it, orient it to how I want it to look. So I know that this lid is going to sort of slide on to this piece like so. So if you see these grooves in here, I'll try and orient it. So you can see this sort of like L-shaped grooves in here, right? So that's like the slot where our lid is actually going to fit in. You can see the same geometry on our lid. So you can probably already, if you go back to the constraint menu after you orient your part, go back to constraint, you can probably already have an idea of how you can put this part together, right? So for example, you could click this face, right? And picture how this lid is going to slot into your base part. It's going to follow along these grooves until it goes right to the back. And when it goes right to the back, this face that I just selected here is going to be pressed against the inner wall of our base part here, this one. So if I click both of those, it actually puts them together right away. Bam, just like that, right? And technically I could hit OK here, right? And you can see it still doesn't look right. You know, it's lopsided almost, right? If I click this, I can still drag it around. It's not constrained in place. However, if I try and put it left and right here, that's pretty bad visual actually. Oh, let's see, I've dragged it out into the middle of nowhere. So just be careful when you're doing that. It is constrained at that point. Whoops, Jesus, oh my goodness. Okay. Sorry, it looks like I've made this a little messier than I was supposed to. But it can't actually move in this direction. So it's still unconstrained, you know, up and down vertically. Like it can go that way, and it can go left and right from this orientation, this viewpoint here, right? So I still need to give it some more constraints so that it can't move in those directions. I want it to be solid in place. So you can probably have a good idea of how to do that. You go back to the constraint menu, you keep a mate on again, and let's say I want to constrain it just in the up-down direction. So if I can click the underside of my lid here, the top underside that I've selected here, just make sure you select that one, sort of where the curved edge comes down, and then it's just got this flat portion. There's some undersides of holes in there, and then you select the part on the base where that will clamp down onto. So once you select both of those, bam, Inventor will just put it right there for you, right? Now if I click OK again, I just want to show you guys, you can keep your constraint menu open if you want. I just want to show you how it can move now. So the last direction we have it unconstrained is here, right? So it's just kind of morphing through the part, right? It's just phasing through it like a ghost. So it's still unconstrained in one direction. And now you can probably figure out this last part on your own, but you just line up some mate planes going in that direction where the normal vector is coming out, right? By normal vector, I mean, if I hover over this plane, you can sort of see near my cursor that arrow coming out of the plane. That's the normal vector coming out. So if I just go ahead and click that, so that's the underside of my slot edge, the sort of wider part. If I go back onto my base part, I can find the corresponding edge in here to give you another angle of that, I guess. I could do that. It's this edge right in here. So you click that down, and then you click OK. And now if I try and move this around, it cannot be moved. It's constrained in all directions. So that was kind of sort of the core process of putting stuff together, right? It's quite easy when you have all these normal planes that fit together so nicely and everything's a square. You'll see as we add more parts in, there's a few more ways of dealing with constraining these parts together. For example, if you're trying to fit a ball in like a semicircular slot or something like that, right? Or if you're trying to set something at a certain angle from something else, there's a lot of constraints for that in the constraint menu. But now that we've put at least one part together onto our base part, I'm going to take a 1-minute break, and then anyone feel free to pipe up in the Discord if you have any questions. right, looks like the pace is good so far. There is a poll in the workshop main chat, so if you guys feel I'm going too fast or too slow, go ahead and voice your opinion on the dino poll there. Why do I feel like such a boomer when I do this? I don't know. The dino poll. Yeah, so it looks like there's some questions going on in the chat. That's awesome. Glad you guys are reaching out and getting help. Looks like Kieran and Aiden are on the case, so I'll leave you guys to that. And if I go back to, oh, that's the wrong page. I'm going to go to my handout, and what is the next part I'm going to put on here? I think it's the legs, actually. Yeah, so the next parts I'm going to be putting on, if I go back to my reference assembly here, which doesn't actually have all the parts on it that we need, but that's okay. So I'm going to hide my plane here just to show you guys a bit better. Next parts we're going to be adding on are these support legs here. So these ones. Now if I kind of delete one of these just to show you, since they're mirrored anyways, you can see there's a middle hole here that sort of fastens the leg into place with a screw. And then there are just some circular slots that these legs actually go into. So there's actually corresponding circular slots on these legs. If I just kind of show you guys real quick. See, it has these. We made this one in workshop 1, so you guys might remember the shape of it. If you finish the workshop and you're comfortable with your part, you can actually add it into your assembly. If not, you can use the required files. So this is what we're going to be adding in now. I'm going to go ahead to place component, and I'm going to go to workshop demo drone leg. I think that's the one. Go ahead and add that. And we're going to be placing down 2 of these. So make sure, again, just to reiterate, go to place, workshop demo drone leg. I think that was what it's called. And then just go ahead and place down 2 of them. So this time you can click twice. So that's sort of why the place tool does this. It makes you click escape when you're done. Because a lot of the times you're going to be placing a bunch of the same part. For example, if you have like a plate going on, like a cover plate going onto something, and there's 8 screw locations, you're going to make 8 screws, right? So you're just going to click a bunch of them down. So once you've clicked 2 of these legs, you can click escape on your keyboard just to exit out of that tool. And so luckily that we have 2 of these, I'm going to do it once at a slow pace, and you'll get to see me do it again at a faster pace. So same principles apply as last time, that sort of to make your life a little easier. So I'm going to select one of my legs, doesn't matter which one, just whatever one you want to do first, and then hit G on your keyboard, or go ahead and click free rotate up here. Both of them work. And then just orient that part so that it doesn't have to be exact, right? It doesn't have to be exact because the constraints deal with the exact angles and stuff. I'm just trying to make this look sort of in the right orientation, vaguely. As long as it's not like upside down, essentially. So as long as you have it oriented somewhat nice, yeah, like that'll work. Just go ahead and click escape after you're done doing that. Or you can I think you can actually just click in the space as well. But escape is your best friend when you're using Inventor. So now, how would I constrain my leg to my bottom here? So there's a few ways. First off, remember we have to constrain it in all axes, essentially, right? So we have to constrain it going this way, going up and down, and then what's the other way? I haven't said yet. Doesn't matter. One thing I find super easy, super useful actually, is that Inventor is actually quite smart in some ways. In a lot of ways it's really dumb, but in some ways it's quite smart. So for example, if you go to constrain here up at the top, if you don't touch anything in the constraint menu, if you just leave it alone, and then if I go to my part that I'm trying to constrain to my main assembly here, so there's a few ways you can see it going on. For example, you can put this face onto the upper face, just like that. That's probably the best way to constrain it in the vertical direction. But how would we constrain it sort of in the left, right, and in the page, out the page direction, right? So there's an easy way to put this, to essentially put these circular extrusions into these circular slots. And it's actually really intuitive. You just hover over sort of around the center point of your circular extrusions here, and you'll see that there's this long white dotted line that's going all the way through it, just kind of bisecting through the center. That means it's selecting the axis. That's exactly what you want. What we're going to be doing is we're going to be selecting the axis of our circular extrusion here and the axis of our slot, and it's going to connect them. It's going to align them. So if I select that, once you have it selected, it'll turn blue, or maybe a slightly different color depending on your visual settings. And you do the same thing for here. If you want, you can even hover over it and it'll show up as axis here, and you can just click on the axis button. So as long as you do that, bam, and it goes into place just like that, right? One thing you might notice when that happens, in your constraint menu, it's not a mate here anymore, right? It was a mate before we made this feature, and that's because Inventor automatically detected what we were selecting. It detected that we were detecting that we were attaching two axes together, and so it automatically went to the insertion features. So just keep it how it is at the moment. Opposed is exactly what we want in this case. So if you just go ahead and click OK there, or you can hit apply as well, you can see that it's now constrained about this axis. So we can actually move the other slot, but we can't move this slot out of the orientation of that hole, basically, if that makes sense. Now to fix this sort of rotational issue that we have here, we can just do the same thing with the other hole. It's quite nice that we have two in this case, just because that'll constrain us entirely in the sort of horizontal field. So I do the same thing. I go to constrain, I go select the axis bisecting through this this cylinder, this small little cylinder, and then I select the axis going through my circular slot on the bottom side of my base, and it should line them up. If you had it already somewhat looking aligned, then you'll see a sort of micro adjustment there. And then if I just click OK, just to show you guys again, now you can see that we're entirely constrained in the horizontal field. I can only move it up and down. And you might remember from earlier when I mentioned how we can constrain this, this leg vertically compared to the base. It's super simple. It's the same thing we did for the lid. You just go to constrain, you keep it on the mate here, and we're just going to be mating this face to the bottom side of our base. Just like that. So you can see now it looks pretty much exactly perfectly in place, right? You guys don't have to do this for yours, but just to show you one thing that you can do if you want. So if you go to your parts here on the left side, this is your model tree or your assembly navigator, whatever you want to call it. You have all the parts that you've so far placed in your assembly here. So like my central unit body is here, my lid is here, my leg 1 is here, which we haven't touched yet, and my leg 2 is here. And if you expand your leg 2 now, you won't have to do anything here, so you can just watch if you want. But if you expand your leg 2, you can see it's got some work planes on it, but it's also got these constraints that we just made. So we have our mates, our axial mates, I suppose. So our first one there, you remember when we did that, and our second one is there, same thing. And we have our face-to-face mate here as well. And now Inventor does have the option, if you want to sort of offset something at a distance, you can go ahead and click on that constraint, and you can actually give it an offset. So that's what this dimension box is asking for. So if I wanted to make this 2 millimeters lower, then I just type in 2 millimeters there, and it sort of offsets it a little bit. In this case, we don't really want to do that, but that's something you can do. If you want a part to be sort of not necessarily made it to something, but you want a tiny little bit of clearance, you can fiddle around with the offsets to try and make it look like how you want. So I'm going to attach the other leg now. Probably going to speed through it, but so you guys will get to see it a little bit. And then after that, I'll take another break if you guys have any questions. So I'm going to go ahead to, I'm going to zoom in. By the way, before I do this, if you guys are wondering how I'm rotating, I can reiterate here. You can do Shift, you can hold down Shift on your keyboard, and you can use the middle mouse button, click down on the middle mouse button on your mouse, and then it should rotate the screen around, just like this. And you can use you can left click on the view cube as well to get some similar movements. I find just using the mouse button a little more precise. You can get these really little precise movements. But anyways, I'm just going to go ahead and do this. Constrain this axis with this one. And if you want to do these without, I guess, without closing the constraint menu, you just click Apply, and then it'll keep the constraint menu open, so you can make rapid constraints, just like this. So you can see I'm clicking Apply between each one here. And then I only have one more left, so I'm just going to go ahead and do that. Just like so. And then now I'm done, so I click OK. Cool. We have our legs in place now. Excellent. I'm going to go ahead and take a small break now and let you guys pipe up with any questions if you have any. And I'm just going to check the Discord chat. So while we're taking a break here, a few people have asked sort of how do you get the bonus marks, essentially, right? So to get your bonus marks, you attend 3 of these Inventor workshops throughout your school year. So we're having 3 this semester. This is the 3rd one. So last one this semester, and we're having 3 next semester. Now the 3 next semester will cover content that's a little more complex. Like you'll see when we when we introduce the propellers here, it'll be designing stuff like those with sort of irregular edges, lots of curved edges, and we'll be going over some of the more advanced tools that are available in Inventor. And this semester is more about the basic fundamentals of Inventor as well. So to get the bonus marks, you attend 3 workshops out of 6 total. And the maximum marks you can get are 0.5% for your 1P13 or 1P10 course. That 0.5% is set by the engineering department or your prof. I'm not too sure because there's a lot of other clubs and activities you can do and events you can participate in throughout the school year that also give you 0.5%. So they don't want to let it stack up too much. They don't want it to accumulate up to something absurd like 20%, right? Because it is those courses are worth a lot of units, so it does contribute a lot to your GPA. But that's the sort of rundown. If you guys have any further questions on that, let me know. Cool. So I'm going to go ahead and keep going here. I believe the next parts I'm going to be adding in are some little attachments onto the outsides of my arms here for the drone. So those little attachments are going to be the chassis pieces or the holder pieces for the propellers and the motors that go on the end of each arm here. So if I go to place component, and then you can place a motor clip. Now, okay, let me preface something here. Since this workshop is quite long already, and we did get delayed at the start, for the drone, I'm going to be making one arm of it just to start off with, and then when we get to the end, we'll see how it goes. I'm going to be making just attaching all the motor components to one arm just up first instead of all 4, just to save ourselves some time. So I'm going to be going to motor clip here. That's the one we want to place. And I'm just going to be placing down one of them for now. If you want, you can place all four and you can just place them off to the side like this. I'm not going to do that just for now, just for the sake of keeping things nice and clean on my screen. So let's work on this arm here on this end. So you can see a hole here and a hole here. So those ones, we know those ones are going to go, those ones are going to align. And we can see there is a slot on this motor clip that just kind of presses right onto the arm of the drone. So same principles apply as earlier. Just go ahead and select it. Hit G on your keyboard or free rotate up at the top. And you rotate it around. I believe it's symmetrical about this face and this face, so don't worry about if it's upside down or not. So once it's oriented somewhat vaguely correctly, then we can start placing some constraints. Now, for this one, I wanted to try something different. So far we've used constraints, and the handout won't be doing it this way, but I just wanted to show you guys that this is an option. So far we've been using the constraint menu, which is great. It's awesome at getting like really precise degrees of freedom locked down. But if we wanted to just, if we think that the program is smart enough to do something and apply all the constraints correctly, then we can use joints. So joints basically apply a bunch of different constraints all together, all in one go. They're really nice, but they can be somewhat unreliable if you have more complicated geometry and if you're trying to do something a bit more precise. So let me just click on the joint menu and show you. So the joint menu looks a little more simplistic, I guess you could say. As in there's a lot less kind of symbols thrown at your face. But essentially, all it is you select a type of joint here in the drop-down. So far we've got an automatic, but there's also rigid, rotational, slider, cylindrical, planar, and ball. Honestly, I don't recall at a time I think I've used ball maybe once for like a ball socket, joint. But mostly I use rigid and rotational. So we want this motor clip to be rigid in place. We don't want it moving around at all, right? We don't want it rotating. We don't want it sliding up and down. We don't want it sliding off and on the arm. So we want it to be rigid. So go ahead and select type of rigid. And now I'm going to select, let's try and put, the back. See the back? If you sort of look inside the motor clip, it's got the back of the inside, I should say. So if I select that, now that it's transparent, you guys can see the edge I selected. So you're gonna have to look on the inside of the motor clip to actually do this. I'm gonna do this again with the constraints, just so you guys know that there's multiple different ways. So I'm selecting the back here of the inside pocket, and then I can select the face that it's going to be pressed up against. And you'll see it'll give me this nice little animation. It'll shake around to show you that it's rigid. And look, it's perfectly aligned. It's perfect. It's in place. It's done. It's all done for you. Right? If I try and click and drag this around, it can't be clicked and dragged. It can't be moved. It's done. So yeah, your life can actually be that much easier than what I've shown you with these support legs and with the lid and everything. It's actually, Inventor can be quite smart with really simple mates and stuff just like this, because it kind of detects the overall geometry of the parts that you're trying to fit together, and it just fills in the blanks essentially. The reason we started with constraints is because joints are made of constraints, and it's really important to understand what the program is trying to interpret from you, right? It's important to understand how to tell the program what to do, especially when joints don't work for you, or they work but they're not exactly where you want them to be. There's something weird off about them. So it's really important to understand constraints first. So in case you need to use the constraints sort of piece by piece, then you can still go back and use them. And your TAs for your courses will probably prefer that you use constraints over joints. But joints are still really nice to know how to use. So that's how it is with joints. You can see that you probably realize it's so much easier now, right? It's just so much nicer to use joints. I'm going to use a mix of both from now on for the rest of the parts. If you want to know how to do that part with constraints, you can refer to the handout, or you can probably figure it out on your own. Just kind of connect the axis of this hole with the axis of that hole, and then just connect the back face that we selected earlier with the end of the arm that we selected earlier as well. Now the next pieces we're going to be putting in, I believe, are the motor bases. So if I go to place up at the top, I go to motor base. I did that rather quick, so I'll show you again. Place motorbase.ipt and open, and then you just place it down. Then you hit escape, just as we do earlier. I'm going to delete the one I just made. And then I'm going to, so how this motor base goes onto here is it's actually oriented like this. So the rotational axis, the axle here, I guess, is going to be poking out of the top of our motor clip. So you can probably think of a few ways of putting this on. If you want, you can try using a joint and try maybe selecting this this face here with the bottom of our circular face here. I'm going to use constraints for this one because I think it can be done in two constraints. So if I go to my constraint tool, just up at the top as per usual, you can start however you want. If you want, you can do it vertically, just like this. So I can tell just by looking at the geometry of the part, right, that this face is gonna be mated with this face. It just looks like it, right? I mean, you can sort of tell just by looking at it in this case. So if I just select this face as it's pointing up, and then this face on the bottom of my arm, of my motor clip rather, and voila, it just puts it on just like that. So you can see it's constrained. Oh, well, that was a bad way of showing it, but it is constrained up in the vertical direction now, but it's not constrained sort of left and right, right? So we can apply another constraint to it, similar to what we did earlier. We can mate the axes, just like this. I can show you that again, just in case you guys are still getting the hang of it, which you probably are, which is totally okay. I remember assembly at the start of learning Inventor is the weirdest shit, because Inventor will it'll beep at you, it'll go boom boom, or it'll tell you there's too many constraints, and it'll open up this stupid menu. Actually, I'll show you the stupid menu. So I've already got it constrained up and down. But let's say I tried to add another constraint that would use those planes, right? So for example, I have this, where my cursor is, I have that plane already used in a constraint. But if I try to use this plane, I try to make it, for example, if I try to make it, let's say, flush, so that is where they're sort of the normal vectors are aligned or parallel. If I try to make it flush with this face, and I try, see it didn't automatically place it. And if I try to click OK, oh, well, now it's, of course, now, oh, of course it works because that's another way of constraining it anyways. Embarrassing. Okay, if I try to do the same thing, if I try to do the same thing with this face and this face, and I click OK, it gives me this menu here. The assembly cannot be solved. What that means is, well, it tells you here, the new relationship conflicts with existing assembly relationships. So that's saying you can't have two constraints that tell you to do different things with the same sort of directions rather. So when I tried to add this latest constraint, I wanted to make this top axis, this top face aligned with this top face here. But it's already, the way we have it is it's already going to be poking out of the top because we already have a constraint telling this face to be mashed up against this one. And you can't tell it to do two different things, right? So yeah, that's just essentially what that means. If you get that error, you have to go back, delete, go into your part here on the left, go into the part that you're trying to add constraints to, and just delete whatever constraints you already have, or investigate. You can click on the constraint and it'll show you the pieces of each part that are trying to be put together. And you can sort of infer from there and try to figure out what exactly is conflicting. And usually the best course of action is to just kind of delete the constraints that you have, start over. But once you get the hang of it, it's not that much of a time loss. So I'm going to add my next constraint here. I'm going to mate this axis. And I'm going to, with this one, bam, just put it into place just like that. Let me know if I did that too fast. Yeah, I guess I'll take another 30-second break. Feel free to pipe up in the Discord. I can definitely hear you. If you're in the workshop main voice channel in the Discord, I can hear you. So if you have any questions, let me know. Just pipe up. I'll wait about like 30 seconds or so. We are getting around to 8 o'clock, so I'll try, and if you guys have already gone ahead and finished everything, I'm going to share the exit survey with you guys. I'm just going to put it in a workshop. I'm going to put it in announcements because it looks like some people are talking on workshop main, which is fine. Here is the submission form. So that's the Google form for filling out, just so you can get your bonus marks at the end of the workshop. It's just a short survey, essentially like, what can we improve with this workshop? I know there's some technical difficulties at the start. We're just trying to get, I guess it must have just been an internet connection thing, honestly. Just with the delay on Aiden's computer by about like 10 seconds or so, which is you know, it happens. So I know that's definitely something. If you can't think of anything else, put that. We'll try and get it fixed for next time. But what you liked about the workshop, what you didn't like about the workshop, let us know. If you want, you can just put NA for them. Doesn't matter. And then you're gonna need to upload an STL file of your part. And if you've already gone ahead or if you have to go, if you have a midterm at 9 a.m. tomorrow or whatever, that's totally fine too. But to actually complete the form, you're going to have to save your file, your assembly file, as an STL. To do that, I'll just show you really quick. You go File, and you click the arrow next to Save As, and you go to Save Copy As. This is one of the ways you can do it, or you can do Export to another CAD format. I always go to Save As, Save Copy As, and then you give it a name, drone assembly, right? And to save it as an STL, you click the drop down on Save As Type, and you go to STL files. Here, it should be sort of near the bottom. It's called .stl, and you click that, and then you save it, and then you can upload that to the Google form. Make sure you fill out the Google form because that's how you're going to get your bonus marks. If you're not in Engineering 1 or biomedical engineering, and you don't need the bonus marks or whatever, if you're not a first year, then that's cool. Don't worry about the form. But I'll keep going here. Now that I've given you that spiel, I'll give that spiel again later on for saving the STL as well. So if you missed it now, don't worry. But if you really, really have to go, just ask in the chat how to save as an STL, and someone will help you out. So the next part I'm going to be adding in is called the motor holder .stl here, and it's this one here that has this these sort of semicircular cuts out of it, these 90-degree angular cuts, like a sort of disc almost. I'm going to go ahead and click that. I'm going to open it and place it in. If I just kind of inspect my part here, you see that it's not symmetrical about the faces here, because these sort of little slots, almost, well, not necessarily slots, tabs I should call them, are sort of flush with this side, but then there's about maybe a 10 millimeter gap between them and the other side. I'm just going to check my handout just to make sure we know where they go. Yep, okay, that looks about where they go. So I'm going to rotate this and rotate it so that it looks like this, I believe. So once you have it kind of oriented to look like this, it'll make your life a little bit easier. And we're going to be making this with constraints again. The next one we're going to be using a joint for is the propellers. So you can get ready for that. I'm going to make a constraint here. You can probably guess how I'm going to do this. But, for example, you can use the axis of this inner circle here along with the axis of this, of the motor base here. And then you can put that face onto this face so that they're aligned just like this. So I did that with a mate. Did someone have a question? I think I just heard something in Discord. Oh, never mind. I'll just. I think he's just accidentally. Make sure you just mute yourself, guys. If you're talking, unless you have a question, in which case speak up. I'm not sure if that was a question or not. But you can see I constrained this face. Yeah. Mm-hmm. That's a very good point. Yes. Thank you, Kieran. Appreciate it. So I did exactly just what Kieran said. If you go to View tab up at the top here and you click Degrees of Freedom, it'll show you the degrees of freedom for all your parts. You can see that there's no... basically, to tell where the degrees of freedom are, look for the arrows, essentially. So if I zoom back in on my parts here, you can see my motor clip that I just placed in. It still has 2 green arrows. And basically, it's telling me that this part can still move in those directions. It can still be translated in the directions of those arrows. So, for example, if I click and drag it, I can still move it around. Additionally, this is an important thing. If you're doing simulations, you can see there's actually a rotational axis degree of freedom there. That's this little red arrow down here. So that's a really important thing as well. If you're doing dynamic simulations and you have something that can rotate, that's not supposed to be able to rotate, you actually have to make a constraint there to make sure that you constrain it in the rotational direction. So before I continue on with this part, I'm going to fix this because this can still rotate. You can see here, I'm not sure if you can see it over the stream, but it's moving. You can see some pixels shifting around there when I'm trying to move it. That's because it's not constrained in the rotational direction. So to actually fix that, this is where it gets a little freaky sometimes. This is the part that tripped me up when I first learned Inventor. So to actually fix this, you have to set you have to make an angle constraint with the plane of your part and a plane of another part in your assembly that's fully constrained. Let me show you what I mean. If I go to my motor base here, in the left-hand side of my screen, and I expand it here so I can see my model states master, I can see my origin. If I expand my origin, I have these planes. So what I want to do is I want to make, it doesn't matter like which plane I use between YZ and XZ, because what I'm going to be doing is I'm going to be making this, I'm going to be telling the program that this plane has to be parallel with another plane. For example, like the side of this motor clip here. This motor, yes, that's the motor clip. So I'm going to right click my XZ plane here on the left hand side. I'm going to enable visibility of that just so we can see what we're doing. Now I go back to the constrain menu. Now, in the constrain menu, to make this parallel, there's nothing that says parallel, but what you can do is if you go to type and you go to the one that says angle here, you can select this plane, and you can set the angle between them to be 0 degrees, which is the exact same thing as making it parallel. To do that, go to the first solution here under angle. First solution, the one that says directed, if you hover over it, directed angle. You keep this as 0 degrees. You select the plane that you just made visible, and you select the plane that you want it to be parallel to, and there you go. You click OK, and you can see that my rotational degree of freedom has now disappeared. And now I'm just going to hide this plane again and get rid of visibility. And don't worry if you guys missed that, because I'm going to be doing the same thing for my motor holder as well. So I still need to kind of align the axes of these things. I can always just do that, but I'm going to be using a constraint here. I'm going to mate. Try and hover over the sort of angular circular arced face here to try and select the axis. If you hover over it and you just wait, if you just keep your cursor still for 5 seconds, this will pop up, and it's basically asking you like, did you want to select this axis? And if you just click on the axis, bam, that's what I wanted to select there. And now I'm going to select the corresponding axis that it's being mated to, just like this. And it puts them together just like that. If I hit apply, cool. So now you can see I have 1 degree of freedom left. I have this rotational constraint, rotational degree of freedom, sorry, on my motor holder. So to fix that, I'm going to do the same thing I did for the last part. You go into the left-hand side here on your model tree, you expand the origin folder, you find a plane that you want to make parallel with another plane already in your part, or in your assembly, I should say. Just make it visible, just to make your life easier. You go back to constraint, angle, directed angle, and then you click both the planes that you want to make parallel. I know there's a lot of buttons to click, but just to reiterate, constrain, under type you go angle, under solution you go directed angle. And now I can select this plane that I just made visible, and I can select this plane on my assembly, and now there's no more rotational degree of freedom, and we're good to go. So that's how you put the motor holder in place. And now I think it's time for the propeller, but I could be wrong. No, it is time for the propeller. So yeah, it's go time. Let's go. If anyone has any questions, just like straight up interrupt me. I'll probably keep talking for another 3 seconds, but that's just because the stream is delayed by about 3 seconds. If not, I'm gonna keep going. Please voice any questions in the help channels. Looks like Kieran's on the case in there, as well as Aiden and Val, so awesome. And if you guys ever need one-on-one help, it looks like Val's chilling in help room 1. So if you need to share your screen and you need someone to show you, Val is a very, very friendly man and he'll help you out. So I'm going to go ahead and go to place up here in my top left. I'm going to find my motor propeller or drone propeller. Sure, drone propeller. Just go ahead and click that. Click open. So it'll give you this translucent tool view again. Place it down. Click escape. Awesome. And you can see actually, worth noting that when I place it down, you can see it actually shows me the degrees of freedom it has. For example, it has all the degrees of freedom possible right now. It can rotate around every axis, and it can be translated along every axis. So we're going to be fixing that. First, follow the same principles I used earlier. I'm going to G to open up my rotator tool, I guess. I'm going to try and rotate it so that it's not upside down. That's pretty much the only important direction it needs to be rotated in for this step. Looks like there's a question in the chat. Oh, so there's someone had a question in the chat. If you guys refer to the help room 1, every part is translucent except for one of their parts. I'll show you why that is. If I go ahead and just like, for example, if I click the base, if I double click it, this is what happens. It makes everything else translucent and except for the part that you double clicked. But you'll notice it put me into the 3D modeling environment. If you see up at the top, you see all my tools changed from the assembly tools, right? You recognize these ones from the 3D modeling tools. You can now have extrusions, revolves, all that. So if you need to edit a part while you're working in an assembly, you can actually double click it to go in and edit that part. So for example, I'm getting sidetracked here, but just to show you guys real quick. If you accidentally do this, by the way, just click return. And it takes it back to the assembly environment. But for example, if I wanted to make parts, for example, if I wanted to make just a hole, just a random hole here on the side, I'm going to have to constrain it really. Then I could just do that. Now I could do it all the way through, but I'll do 2 there. And I can make edits to my part while I'm working in an assembly. And when I click return, that hole is still there. So if you guys are going through an iterative design process to go change your parts, you don't actually have to go like file open and open them up on their own. You can actually just double click them, make some changes, then click return. So that's pretty nice. Most CAD programs will have that capability. But back to the matter at hand, I'm going to be attaching my propeller onto my motor here. Now, I said earlier, I'm going to do this with a joint. So I'm going to go ahead up to my joint tool up at the top. And this time, since we want the propellers to rotate, we want them to spin, I'm going to go ahead to type, and instead of rigid this time, I'm going to select rotational. And once I have that selected, now I'm just going to select two faces that are going to go together. Let's say like this face and this sort of interface. Whoops, sorry if that looked a little sickening to you guys. I'm going to peer into the inside of my propeller here. See where it fixes on that interface there on the inside of the hole. I'm going to click that. Now that it's transparent, you guys can see better which one I clicked. You can see the center of the face that you clicked. It's marked by that green dot. There's also a little blue outline there as well. So that's the one I clicked. Now, actually, the very important part of assembly is actually knowing where to click. Obviously, as you can tell, if you just slightly click off of the edge that you're selecting, the program thinks you're trying to do something else, and it screws up entirely. So I've selected that face. Now I'm going to select this face that it goes on top of. Bam! It gives me a nice little animation. It shows me that it can spin. I'm going to play the animation again because it looks so good. There we go. But yeah, that's how you put the propeller on. If I wanted the little gap there again, you could do the same thing. I could go back to my drone propeller here, and I could, well, after I click apply, obviously, I could go into my rotational joint here, and then I can give it an offset, right? Like if I wanted to be slightly up. Whoops, that was 1,000, not 1. 1 millimeter, please. There we go. Now you can see it's been lifted up by 1 millimeter off the top. So if I didn't want that to be like perfectly pressed on, like entirely there, that's what I want to do. But I'm just gonna go back, put that back to 0. There we go. So we have our propeller on, and you see that there's a degree of freedom on it, but we want that degree of freedom in this case, right? Because our propellers are gonna spin. Otherwise, they don't do anything. Otherwise, they're just kind of like knives, I guess. So yeah, we have our degree of freedom on it. It looks good, nice, and you can sort of see our drone has really come together, right? It's looking pretty nice. You can see if we went and put more of these components around on these other arms, we'd be almost done, right? The last thing that we really have to do is add some screws into here. And the antenna, I believe, is the last part. Let me just check the handout just to make sure I'm doing this in the right order, not confusing you guys. Cool. I'm going to go ahead and place the antenna on now. So if you go to place up at the top left, and you find the antenna.ipt, you just go ahead and open that up. Bam. And place it on your screen somewhere. And now we're just gonna. This is a part where orienting really comes into play, right? So we're just gonna orient it like that because I think, yes. So we have a slot here where the antenna can be pressed into place. And then we have a corresponding circular extrusion on the actual antenna piece itself. So if I go ahead, I click constrain here, I can constrain the axes together. So I can click on the axis of this circular extrusion here. Then I zoom out and zoom in on my antenna holder per se. And then I click on the axis on that. Bam! There we go. Place it in. And you can see we still have another degree of freedom here. Just like that. So we want to fix that. You can fix the rotational one first or the translational one first. Doesn't matter. I'm going to fix the translational first. I'm just going to constrain it. Constrain this face here of the circular extrusion because it's going to be contacting the inner edge of the antenna here, just like that. Let me know if I should do that again. This is the most important piece. Obviously, you guys are more than welcome to rewind the YouTube stream if you want. It's also being recorded as well, I should mention. So it's on YouTube, so it's being recorded. So if you guys want to come back later and rewatch the workshop and see exactly what I did, if I clicked something specific or if I neglected to mention anything, this workshop's being recorded. You can find it on our channel. Basically, after the workshop's done, you can go back and check it. So I just have one last rotational constraint left to do. To do that, it's the same principle as the last pieces we rotationally constrained. I go here, I expand it in my model tree. I expand the origin folder. I find a plane that's sort of suitable here. So yeah, it looks like I can make. Oh, actually. Oh, so I'm gonna have to. Oh yeah, sorry. I don't even need a plane for this. Sorry for confusing you. I don't need a plane for this because I actually already have a straight edge on this. I've got a straight face, flat face here. I've got a flat face here. I can just make those. I can just set the angle between those to be 0. So to do that again, you go to Constraint here up at the top. You go to the Angle. You go to Solution, Directed Angle, the leftmost one here. And then you select the face on the part you're trying to constrain. And you select the face that you're constraining it to on somewhere else in the assembly. Select it. There you go. It's now constrained rotationally. If I click OK and I try to move it around, it can't be moved around, and you'll see the degree of freedom symbol is now gone. So it's just like that. I can take a quick break now if anyone has any questions. Wait another 30 seconds to a minute. I also need a drink of water. My God. All right. Let me check how that poll's going. Got 1 vote for too fast and 1 vote for too slow. 14 votes for just right. So I guess status quo. I'll keep going at the current pace. I'm just checking the help room channels just to make sure everyone's getting the help they need. Looks good. Cool. So the last pieces I need to put on are, it looks like the screws. So do we have the screws in here? Let's go place up at the top. Yes, we have screws. Thank you, Leo. So just go ahead and click screw. I think that is the last part, right? We've placed all these other parts so far. Propeller, base, clip, holder. Yep. Leg. Cool. So it's just the screws now. I think the same size screws are used everywhere. So since I haven't placed my other motors and propellers yet, I'm just going to place down 3 screws. Why 3? Because there are 2 screw slots here, and I think this is a screw slot as well. Typically, you would also have probably a nut accompanying this coming down on the other opposite face here. But this is just for educational purposes. So I'm going to go ahead. Actually, let me try and see what happens if I don't reorient my screws first, right? If I don't do the G and orient them around, which I just started doing, but whatever. So if I go to constrain, and if this is perfectly sideways, basically, if I try to constrain this face, the bottom of my screw head here, and I try to put it on the whole face that's going to be contacting, there's a 50-50 chance that it's going to be upside down. 50-50 chance it's either going to be right side up or upside down. So if we click it, let's see what happens. Inventor was smart today. It put it in the right orientation, but I can't tell you how many times Inventor has randomly put a screw upside down when it should have been the other way around. So it did it the right way this time. You can see there's no arrow going up and down on it, so it can only be translated in this direction and rotated around. And same principles apply. You can mate this axis to the axis it's going into, just like that. And there's also a rotational constraint, rotational degree of freedom that's left in it, right? Just to save ourselves some time, I'm not going to worry about that for now, but if we wanted to, you just do the origin, show a plane for it, and make it visible, and then use the directed angle constraint to make it 0 degrees between, let's say, that plane I just had selected and, for example, like this face of the drone here. Now I'm going to try the same thing with a joint, just to show you that there's 2 different ways we can do this. So I'm going to go to joint up at the top. I go to type. I can make a rigid joint so that it, for example, if we wanted to get rid of the rotational aspect of this, and I just selected the same face I did last time, and you can see it's sort of there, right, sort of in the middle, on the inside of the part. And I select the same face I did last time. Make sure that green dot is in the middle there. Let's see what it tries to do. Ah, damn. It did it right. That's disappointing. The pessimism didn't work out this time, but that's okay. So it actually, when you use the joint there, when you use the rigid joint, you can see this one, when I use constraints, because I was too lazy to go and do the directed angle thing on it, it still has a degree of freedom. But since I made this other one with a rigid joint, rigid means it's not moving anywhere. It's stuck in place, right? Constrained in all directions, even rotationally. So you can see there it does not have a degree of freedom symbol on it. That puppy's not going anywhere. So, yeah, that's how you put screws into place. It's more or less more of the same thing, right? That we've already done. So yeah, if I wanted to put this one in place as well, I think it just uses the same screws, right? Yeah. So if I just make another joint, make another rigid joint here, just like this, I go select that face, just like that. I go back over here, and now sometimes when you're doing joints here, it's very, very important to click correctly. So if I clicked it here, I can't really predict what it'll do. It'll probably do it correctly, but I know it's going to. I know I clicked this face, and I want that green dot to be touching the next green dot. So as long as this green dot is here right at the top of the hole, then I know I'm going to be okay. So if I just select the edge there, aha! It put it upside down. Confirmation there. So yes, it put it upside down. If I try and flip it there, bam. So Inventor is actually pretty nice. Sometimes, if you're using the joint tool here, there's actually an option that lets you flip the component. So if it puts it in upside down, you tell it not today, and then you click this little button here that says flip component, and it'll go upside down or right side up, and that's how you fix it. So if I just click the animation there, it'll show you that the screw can't move. It's stuck in place just like that. And yeah, that's how you do it. I can do it again if anyone needs to see it again, but we are definitely running low on time. For the submission link, it's in the announcements channel. I'm gonna ping everyone there now. I pinged everyone again. So the submission form is there. That Google form link. It's just you put your first name, your last name. Here, I'll show you. So you put your first name, your last name in here, just like that. Faculty, whatever it is. Year. So most likely, most of you are in first year. If you're enrolled in a course, let us know so we can give you those bonus marks. Give us your McMaster email so we can give you those bonus marks. Student number, same thing, man. What did you like about the workshop? Areas for improvement, let us know. I read most of the feedback last time. It was pretty awesome feedback. Thank you so much for that. I know some people mentioned, a few people definitely mentioned like, oh, I wasn't sure how I was supposed to ask questions or not. If there's like a live question and answer session, so like, feel free, speak up. You saw Kieran speak up earlier. That was over the Discord. That wasn't over the stream. So yeah, feel free to ask some questions in here, and let me know. And then of course the last thing is saving the STL file. I think let's see in the hand. So I think I've actually completed everything we wanted to show you guys today. I might do a little bonus part afterwards if anyone is interested in a shortcut for putting the rest of the motor components on these other arms. There's a really quick way to do it. You don't have to add any parts individually. You can actually just pattern all the components. So I'll do that in like 10 or 15 minutes or whatever. But consider the workshop now done. Thank you so much for coming. We really appreciate it. I hope you guys learned a thing or two. Again, if you had any trouble, you can view the YouTube stream again later on our channel, or ask any questions in the Discord server. If you have any CAD questions throughout the week, let us know. There's a section in the Discord server called Help Center, and you can ask some general questions in there, and we'll be more than happy to help you. But yeah, for now, just go ahead and fill out the form. save your part as an STL here, or save your assembly as an STL. I'll show you that again. So as long as you have your assembly open here, maybe get rid of this stupid hole if you have that hole here. But to save this as an STL, you have it open first, obviously, and you go to File. Next to Save As, don't click Save As, go to Save Copy As. Click the arrow next to it or hover over the arrow. Save Copy As. Give it a name, drone, done. And then you click the drop down here, Save As Type. It'll be automatically on Autodesk Inventor Assemblies. You want to change it to STL files. STL files star.stl. Just like that. And then I could actually, with STL files, any 3D modeling program can read them. If you're 3D printing stuff, you use STL files as well. If you guys want me to show you how to set up a 3D print later on, let me know. I'd be down to show you real quick. It's super, super simple. But yeah, so that's how you save an STL. Make sure you have all this save copy as, save as type, STL files, give it a name. I don't know, give it your McMaster name or whatever. You know, if I put Shire1 underscore drone. If you want, you can do that. But since you're filling out the Google form, putting your email in there, don't worry too much about the naming scheme. It's not that important. So as long as you have it set up like this, you can go ahead and click Save. And you can just attach that file here in the form, just like that. So yeah, that's the workshop. Thanks for coming, guys. I'm gonna wait around here for like 5 more minutes or so. And feel free to ask some questions in the Discord if you want. Keep in mind I'm on a 3-second delay, so sorry if I don't react right away, but it should be a pretty short delay. But yeah, I'll chill. And you guys, as soon as you fill out the form, you're welcome to leave. Have a good night. Good luck with your midterms and all that. I think you guys might have one later this week. I'm not too sure. But yeah, thanks for coming. Looks like Val just unmuted. If he has anything to say, I'll let him go now. I don't have the answer for that. That's another person on MDL. I will inform them and let them know to keep it open for at least 24 hours. If not more. I'll try and get 48 hours this time. So, let's say maybe a little less. Let's say Friday at like 6 p.m. or something. We'll close it. Sound good? I feel like that's pretty generous, so. I'm sending her the message now. All right, that has been requested. The information has been handed off. How will we know our 1P13 bonus mark has been given? If you want early confirmation, you can message one of us in the Discord. But as long as you fill out the Google form, it'll be given. Obviously, it won't be given until your course ends, because that's when the bonus is tacked on. But if you are really paranoid about it, let us know, and we can check the submissions. But I wouldn't worry about it too much, because if you filled out the Google forms and you submitted, everything looked fine, then your response should be with us. So if you guys have any questions about your part, I'm more than welcome to help you out. If you are confused about something, I'm still sharing my screen here, so other people might be confused as well. Oh yeah, yeah. Someone just messaged in the Discord. No screws in the legs. Yeah, you can put screws there. You should probably put screws there. I just forgot. But yeah, go ahead and put screws in your legs. Not literally, obviously. Unless you pissed off the mob or something. Not sure. But just to show you how to put the screws in again, just go to your joint tool, set as rigid. Select the sort of bottom face of your screw head there, and you select the face that is going to be contacting. Just there. Bam. Put it in the right spot. Awesome. Since I'm doing multiple this time, I'm going to do the same thing. I don't have to close any menus or anything. Just click the same face here. Whoops. Jeez Louise. What the heck? Okay. That's me trying to censor myself there. All right, so there we go. I'll put the screws in the legs now, just for good measure. Also, if there's something like messed up about your assembly and you're worried about losing the marks, don't worry about it. If you have other stuff to do, you can still export it as an STL. Like for some reason, if you couldn't get the propeller on, it wasn't working or anything like that, don't worry about it. I'm not your TA. I'm just here to show you how to do stuff. But if you want help getting that fixed, let us know for sure. And yeah, don't worry about your part being perfect. It's just marking on basically like, did you do anything? Like basically, you should be able to get the marks if you like at least put on the legs and the lid here. Yes. There's no mark on it. It's just like, did you try? As long as you tried, it's okay. The motor holders are not supposed to rotate, no. So to fix that, what is this, the motor holder here? Yeah, to fix that, you can just, actually, since we have some straight edges here, it's actually super easy to work with. You can go constraint up at the top. You can go angle, directed angle, and you can select that face there. See, that's a straight face, right? That's not curved or anything. So you can actually make that 0 degrees with this one if you want, and do it like that. It's not going to let me do it right now because it's already constrained, but that's a way to do it. Yes, Gavrilo, that's okay. It doesn't need to be perfect. We would probably accept even less than that, so don't worry about it. Oh, can I show you the mirror trick? Hell yeah, I can show you the mirror trick. Okay. Let's start off with like basics. Let's start off with a basic mirror. You don't have to follow along with me, but this is just to kind of show you what you can do in an assembly. So let's say I only had one of these legs on. Let's say I was feeling, I don't know, really lazy for some reason. Even though it would probably be a shorter period of time to just constrain another leg on there. But let's say I didn't. I have this fancy feature called mirror components. Mirror components is nice in an assembly for if you have, like for example, a part. Let's say a part with other stuff like screws and stuff in it. I can just mirror all these parts. So for example, this leg and this screw about a plane, and it puts it, it mirrors it on the other side of the assembly, just like it would in part modeling. So in order to do that, I need a plane. So I need to make a plane that kind of bisects right through the center of my part here. To do that, let's see if I have a plane already or not. That's not the right. Central unit body. Please. And no, but that's okay. So I could try bisecting here. Second, I can make a mid plane between two planes on the plane tool. Try and make a plane that way. So if I wanted to, and of course it's not working right now because Inventor is a lovely, lovely, lovely program. So I'm going to do it a different way. I know the geometry of this drone, for an example. So if I wanted to make a plane that's just going right through the middle of it, I can just drag this out. I know that this is 100 millimeters wide. So I can make an offset plane, just like I saw there, just like I showed you there. You go to the plane tool, offset from plane, and I clicked on this side. And you can actually drag this arrow around if you want, or you can just type in this box. I'm gonna make this 50. 50 is the halfway point in 100, so I'm gonna do that. Once I've made my plane there, I can go up to the pattern or the mirror components tool up at the top. I select my components, that screw and this leg. So you can see it's been added to this menu. And once I've finalized my components there, I go click on this button next to mirror plane. So it knows that's what I want to select now. I select my mirror plane and bam, look at that. That's all you have to do. You just select the parts, select the plane, you're good to go. So in this case, if I click next, oh my God, I don't know why it's making this way more complicated than it needs to be. I'm going to click OK. I see. It didn't actually apply the constraints. Usually it applies the constraints. Let's do that again. Let's see what all that fuss was about. I think you can just do ground new components. But let's try, see if there's another way. Mirror relationships usually fixes that. Or you can do ground new components. Yeah, you know what? Just do ground new components. And now they're fully constrained. Now I'm gonna try. Now I'm gonna do it for my motor here. I'm gonna try this pattern. So pattern is gonna work in a similar fashion. Thing is, you can make a rotational pattern. And in this case, we're gonna make a rotational pattern of all these parts, right? These parts that we put in. So this is 5 parts total, right? So this is gonna save you a ton of time. And picture that 3 more times. All we need to do is we need to have an axis that goes right through the part, like top and bottom, just like that. So we're gonna have to make an axis, which is okay. We're gonna figure that out because it looks like this particular assembly is being a little finicky. But basically, we need an axis. Picture it going into the screen right now, right where my cursor is, into the screen, because that is going to be the axis that we're rotating all of our components about at each 90-degree interval, right? Because these arms are all 90 degrees apart. At least I think they are. So to do that, we need to make an axis first. And let's figure that out. I'm going to hide my work plane. I'm going to make an axis. There's a bunch of different ways we can make an axis here. So the first one is creates a construction line that is attached parametrically to other objects. Let's keep looking. On line or edge. Nope. Parallel to line through point. Maybe if I had a point. Interesting. Intersection of 2 planes. That looks like it'll work. So I'm going to have to make another plane here. Make that visible. Make that one visible. I'm going to make another one. Just in the other direction here. I think this is 90. This one is 90 wide? No, it's also 100. It's okay. So this is going to be another one just in the other direction. Another plane here. Try doing pattern and the feature pattern select on the arm. That seemed to work. On the arm. Okay. Like the arm? Okay. Well, I just know you have to select all the components here. I think that's all of them, right? And for example, if I selected that axis, it's going to do that, right? So I need a different axis. Feature pattern select. Ah, yes, there you go. I didn't even know that was an option. You taught me something. Thank you very much, Aiden. I always just assume this program is really stupid. And I need to tell it to do everything. I always forget how smart it is. So there we go. So let me tell you the reason that works. Because this part, our base part here, if I go into it, because this was made, these arms were all made with a circular pattern feature in the part, you can actually reuse that circular pattern in your assembly, apparently, to actually make your assembly work. So it's nice that that worked out, that we have a circular pattern on the arms. Bing, bang, boom, we're good to go. I can show that again real quick afterwards. But yeah, so that's how you do it. Thanks for figuring that one out. That's awesome. Okay, cool. Learn something new every day. So if I wanted to go back and do it the stupid way, the way I was doing before, if I delete this, I'm going to try and make an axis between these two planes. By the way, anyone who wants to go is free to go, obviously, as long as you filled out the form. You should be good. Did that make an axis for me? I think so, because I can't see it, so I think it's good. Yes, I did. It did. Yes. Okay. So you can see my axis there. You can't see it. I had to highlight it in my left side. But I have an axis now that's going right through the center. So for example, if these arms weren't made with a circular pattern tool when you were making the part, and you had to tell Inventor exactly what you wanted it to do, in that case you would have to go pattern up at the top. You go circular here, and then you go click on this. I believe that's trying to get our, well, okay, I'm gonna click all my components. So you hold shift, you hold control. I think you need to, actually you don't even need to hold control, sorry. You just click all of the components that you want to pattern. You can click them in the environment, or you can just click them on the side window here. Doesn't matter. As long as you have all 5 of these ones selected. And then once you have all the components selected, you go to the button underneath circular here. And you click on this button, and you click on the axis you made, and it does the same thing. So you can see, since we made our axis right about the center here, then we're good to go. But yeah, so I'm going to show the other way again, in case people are having a lot of difficulties, because the other way is a lot easier. So if I just deleted all the things I made, I go back to pattern. Don't even go into the circular part here. You just select all your components. So my clip, my screw, my base, my holder, my propeller, just like so. And then you click the button next to feature pattern select, and you click the arms. Click on the side of the arms. Make sure you actually click on the arms. And then it automatically should recognize the circular pattern from your part, and it should make it. So if you really want your drone to be finished off looking pretty, that's the quickest way to do it. Or you can make some planes and axes like I did. Instant 12, yes. And yeah, exactly what Kieran said in the help room 1. So if a really good practice when you're trying to learn how a CAD program works is just click on a tool and see what the buttons are that you can click. And depending on what you can click, it might just do, you might just teach yourself something, right? I don't know, maybe assembly's not a good way to do that. For example, have I ever used copy before? What does copy even do? I'm not sure. Does it just make multiple instances of like a selection of parts? I don't know, I've never used this before. I can ground them, sure. Yeah, okay, sure. So that's what copy does. There, just learned. Before I go again, if you guys want to know how to copy just a group of parts, you just go to copy, you just select all your components, right? And if you want them to be grounded where you place them, then you tick that off. If you don't want them to be grounded, then you don't tick that off. And you just go to next. I'm not sure what this stuff is, but you can even create a new assembly for them if you want it to be a sub-assembly. So there, I just made a sub-assembly just like that. Is there a question? Okay. But yeah, we all just kind of we're figuring this out as we go. But I mean, obviously we made the handouts, so. But thing is, in CAD, there's just so many different ways of doing stuff, right? There's so many different ways. For example, instead of doing that pattern, I could have done a mirror. I could have mirrored these onto that arm, and then I could have like copied both of those and then rotated it and done it that way, you know. Yeah, there's so many different ways of doing stuff. 41 megabyte STL file. Oh boy. Let me see if there's a way of reducing that. Yeah, so if you want, you can set like the resolution to low. That might reduce your file size. So if when you're saving as an STL file and you click options here, when you're doing the save copy as, and you can set resolution to low, so that'll probably lower the file size for sure. After doing the pattern, when I try to rotate a propeller, it rotates all of them. Oh yeah, look at that, eh? Yep. Interesting. So I think that's because we did the component pattern. So when we did the component pattern, so that's interesting. It doesn't give us any more options there. So if I go to pattern, I select all my parts again. I go to feature pattern select. Aha! So I think that's the it looks like that's the limitation of this method. See, these don't have these elements in here. These don't have, do they have constraints on them? I don't think so. These new ones don't have constraints. Only our first one has a rotational constraint on it. These other ones don't have rotational constraints. So when we did the component pattern select, it since it's using the geometry in the part, I guess it didn't actually copy over the constraints. So if you did it the original way I was doing it, with the two planes and the axis, bisecting between them, I can show that method again. I think that method should retain a lot more of the constraints. So for example, if I, let's say I suppress this. Okay, no, never mind. Don't suppress that because then it suppresses our original stuff. So I'm just gonna delete it. If I go back and do the janky way I was doing earlier, and just make two planes that are -50. Yeah. Oh, that's the way you did it. Oh, interesting. Okay. So let me try and figure it out here for you. The two planes here. We've got our axis going through here. I've done this before and got them all to rotate. Get my axis there. Rotational. Fixed. No, yeah, rotational. Okay. And no, that button didn't do anything useful. Don't worry, don't click that one. What are these green boxes here for? Interesting. Okay, so that's what it did. Hey, interesting. I swear I didn't do that when the first time I did this. I wonder if it's different if instead of using a joint, you use constraints. Because I've definitely gotten this to a point where all of these should be working fine before. Yeah. If desired, you can restore pattern elements. Right-click an independent pattern element and select independent. Aha! Thank you, Kieran. So you can make this independent, and then it'll go do its own thing. The thing is, that it doesn't have any constraints carried over at that point. But I can now rotate this one. But if I made the rest of these guys independent, now I can rotate this one freely, right? Yeah, the crappy thing is it didn't carry over the constraints when I did that. Yeah, go ahead. Oh, yeah. Yeah. Right. Yeah, so it's like another layer of constraints, basically. Yeah, I'm not sure how to. I'm not sure how to. I wonder if you could turn these into a subassembly, and then or make a subassembly again. Can't remember. Yeah, I guess you would need to constrain all of them again. I'm trying to figure out another way to do it, though. Hang on. Christ. I can't remember how to do this. It's been a long time. Hey, Kieran or Val, you remember how to turn all these parts into a subassembly? So that their constraints are all retained? I guess I had, I did it. Okay. That's okay. Yeah, actually now I'm kind of curious. Now, why? Oh, do I have to make that? So, the copy feature I had going earlier was interesting. If I go next, and I go create a new assembly there, then now I have a subassembly. It's all kind of constrained together. But because I based it off the component pattern, it's kind of messed up. So, what if I get rid of the component pattern? Oh. Let's do that. Cool. So if I go here, I copy, next, create new assembly. I just save this as whatever. Assembly 1, copy 1. Now what if I placed that? Oh, I don't know where it saved it. Huh. But I think this would be the way to do it. This is another way to do it. Instead of rotating it around here, you can make a subassembly with a copy. This should, oh yeah, one of these has to be grounded. So that should still rotate now, right? If I save this, oh my gosh, where is it saving? Okay, Inventor. Drawing Workshop. Holder Propeller Assembly. So if I save that as a subassembly, like I just did there, now I can place that subassembly in, and I can constrain it to something or make a joint, like a rigid joint here. Cool, right? And that should, oh great, now it's not rotating. Okay, I'm not sure why it's doing that, because it rotates in here, but oops, but not in here. So maybe if I don't use a joint for that, maybe if I just constrain things around, can I still rotate this? No, why can't I rotate it anymore? That's a little strange. It's almost like it didn't retain the degrees of freedom from the subassembly, which is weird. Yeah. Flexible. Ooh. Which one? Oh. Oh. Maybe I have to constrain it first. Maybe I'll click flexible afterwards. Okay. Wow, why is it doing that? Aha. Flexible. Oh, yeah, that worked. That worked. So I had to constrain it first, and then I had to make it flexible. So they can both be rotated now. So now I can just place the same subassembly in. Whoops. Oh, well, yeah, I guess two works. There. Then put it on there. You gotta flip stuff around just to make it work. And then make that flexible. Right. Cool. Oh, not cool. Let's redo that one. Sometimes the animation fools me. Oops. Nope. That's not what I wanted. Oh, that one worked the first time. Nice. Okay. So, a bit of a longer process, but still quicker than... still quicker than doing them all individually, right? So, I can rotate that one, I can rotate that one, I can rotate that one, and I can rotate that one. So, to reiterate how I did that, I selected all the components, I copied, I clicked next, and then I created a new assembly based off of those. And then it took me into this window, right, where it made my subassembly for me. And I had to just ground one of these pieces of this subassembly, so I grounded the clip. And this can still rotate. None of these other parts can move. So I saved that. I placed it into my assembly. You can place assemblies into assemblies. So the ones that we place into it are called subassemblies. And then I just did some simple joints onto the ends of the arms. And then I right-clicked each of them. I made them flexible. And now they can all rotate. Assemblyception, yeah. All right. I think that's enough for me. Does anyone else have any questions? And if you want to see how I did it later on, I always just refer to the YouTube video. I'll try and post a link to it tomorrow. It takes a long time for it to process, so just depends how long that takes. But yeah, I'm going to come back into the Discord and end the stream now.